large networks. Then route filtering. Yes, EAGRP for IPv6 provides route filtering using a particular command, which is distribute-list prefix list. So use of this route map command is not supported for route filtering for a distribute list. So you have to use the command called as distribute list space prefix list command for route filtering. Then moving on to the components. It has got four important components. The first one is the neighbor discovery. So what is this? Yes, it is a process that every device dynamically learns about the other device which are there in the network. Even the device also should understand and discover the neighbors when they are not reachable or when they are not active. It should be achieved with little overhead with the help of hello packets. We have even seen about the hello packets in OSPF protocol. Here also the hello packets are helpful for the neighbor discovery. Even it can happen at the beginning or even after failure. The hello packets will be helpful for the neighbor discovery. The second one is the RTP protocol, which is the reliable transport protocol. So this helps this enables the EAGRP packets for a guaranteed and ordered delivery to its neighbors. So it supports the transmission of multicast, unicast packets, and also it takes care of the reliability feature. So the reliability feature is not by default. When it is necessary, this is applicable in the EAGRP. Then moving on to the dual finite state machine. So this helps the decision process for all the route computation in the EAGRP. How it is done? Because it tracks all the routes advertised by all the neighbors. So it uses many metrics like distance and cost information, and the main motive is to create a efficient and loop-free paths. When multiple routes are there for a neighbor, it determines this algorithm or the dual algorithm will determine which path is having the lowest metric value, and then that will be chosen and kept in the routing table for further process. And what about the other routes which are having some larger metric values? And called as some this will be called as for creating or generating some reported distance value. So what is this reported distance? It is some total metric achieved. So this has been kept for the further documentation or further analysis. And what about the um, election process of feasible successor? Yes, this also happens and the dual algorithm takes care of it. Finally, about the protocol dependent modules. So when there are no feasible successor to a route that has failed, but there are some neighbors advertising the route, then a recomputation will happen. So this is the process in which the dual finds the new successor. Yes, if there are feasible successes, then the dual algorithm will use them to avoid the unnecessary recomputation. And the protocol dependent modules, it's also responsible for the network layer protocol specific task. Example, the EAGRP module is responsible for the sending and receiving of EAGRP packets, which will be encapsulated inside the V6. And the second functionality is it is also responsible for parsing the EAGRP packets, and it should tell the dual algorithm about the new information which is got. And also it asks the dual algorithm to take the routing decisions, but the results will be stored in the routing table. And finally, this EAGRP is responsible for the redistributing routes which are learned by the routing protocols. These are the four important components of the EAGRP. And then moving on to the EAGRP route authentication. Yes, it supports the EAGRP IPv6 version. It supports the route authentication using the MD5 algorithm, which is the message digest algorithm, message digest 5 algorithm. So it helps in the authentication of the routing updates. And then there is a key